All right, it's 10 o'clock. Let's get started. Good morning, everyone. Welcome to this week's coffee break. My name is Brent Browning. I'm a long sales engineer. Today, we're going to be talking about some innovative products with LF systems, specifically multi-story stairwell and elevator pressurization controls. That being said, I'd like to welcome Scott Blackman, National Sales Manager with RM Manifolds and LF Systems. Take it away, Scott.
Thank you, Brent. As Brent said, my name's Scott. I am the National Sales Manager for RM Manifold Commercial Division. RM Manifold is a controls manufacturer based out of Fort Worth, Texas. We go to market under several different brands. US Draft handles boilers, water heaters, pool heaters, gas-fired appliance drafting. KW is a partnership, and we do fireplaces, pizza ovens, coffee roasters, wood-fired cooking appliances, things of that nature. And then LF Systems is they do laundry rooms, we do high-rise exhaust, and then what we're going to talk about today briefly is stairwell and elevator pressurization systems. So the goals of stairwell pressurization are pretty simple. It's to protect life and property. It's basically to make a tenement environment, a tenable environment for people to escape in a case of a fire in a building. We get a lot of this. A lot of this stemmed from the MGM Grand Fire that occurred in 1980. It was a relatively small fire, occurred in the first floor, but due to a lot of design overlooks, things of that nature, over 60 people died in the stairwells, and it was all due to smoke inhalation. There was no actual fire-related deaths. It was all smoke. Then more recently, here in 22, we had another tragedy in the Bronx with the housing development. There was a 19-story building. 17 people died, 63 were injured. Again, all due to smoke inhalation. It was not the fire itself. When we look at codes and standards, so our codes and standards, we get those from the ASHRAE handbook. We get them from NFPA 92, from IBC section 909. You'll see CONTAM used in this, and that's basically the design software used to study smoke flow in a building. FSCS or FSCP, that's your fireman's smoke control station. A high-rise building, so all of this really kicks in under NFPA at 75 feet or greater. Now, a jurisdiction can lower that. So take the city of Dallas, for instance. They're at 55 feet before high-rise building code kicks in, but they usually can lower it. They don't usually raise it. And then stack effect, that's going to be that natural flow of air through the building. And then rational analysis, that's going to be that computational analysis to kind of show how smoke flows through the building. So when we talk about methods for stairwell containment, there's two different types. We've got a passive smoke control system. That's going to be what you see in your, Holiday Inn, Express, one of those smaller hotels, something like that, 3-4 story building where they've just got doors to the stairwell that close, kind of to keep smoke out. It's one of those best of luck type situations. Then active systems is really where we come in, and that's where you're using supply or exhaust fans, you're using dampers and controls to really control and mitigate the pressure inside those stairwells or hoistways. So NFPA calls for two system types. They have a single point injection system. Basically, that's exactly what you see there. It's a fan dumping into the stairwell at a single point. NFPA allows this up to 100 buildings up to 100 feet. If you go beyond 100 feet, you've got to do a CONTAM study to make sure that it's going to work and work properly. The other type is a multiple point injection system, and this is really what NFPA kind of pushes towards for all buildings. And that's where you've got a fan that dumps into a duct that's either adjacent to or in the stairwell, and that duct injects air at multiple points in the stairwell. NFPA allows you to do up to 3 floors per injection point for the injections. When it comes to the fan location, NFPA says, hey, you can put the fan anywhere you want. You can put it on the roof, you can put it on the ground. If we're doing large buildings, say, 30, 40, 50 stories, you can actually section the fans off. So let's say you can do a 10, 12-story section and put a smaller fan there, so you're not relying on one large fan to do the entire system. Control types. So there's 3 types of control systems out there. according to NFPA. There's a non-compensated system. That's basically where you've got a fan, it's put at a set speed, and it's just a blow and go, basically. It comes on when the event occurs, blows air into the stairwell, and basically relies on doors opening and closing to relieve any kind of pressure or pressure changes. The next is a compensated system. So that's basically going to be a set speed fan, but you're going to have a relief damper or something in there that kind of relieves some of those pressure spikes as you see when your doors open and close. And then a compensated system with modulating airflow. That's going to be really the type of system that's going to actually monitor the pressure inside the stairwell. It's going to keep that stairwell at pressure at all times. And the reason we worry about pressure is we need to be aware of if we put too little pressure in there, we can't keep the smoke out. But if we put too much pressure into the system, we can keep it where we can't open doors. So in this case, this shows this little chart right here. We want to size our systems for about a 0.1, 0.12 inches of pressure. You can keep smoke out at a 0.05. But you don't want to go above a 0.3. And the really reason for that is if you see there, if you've got a 14-pound door closure, with a 32-inch door, if you go above much more than, 0.3, you're going to fail the door pull test. So the door's going to feel like it's locked when you try to push on it. So we want to keep it right around that 0.1, 0.12 when we're sizing these. So UL 864. So UL 864 and IBC have kind of walked alongside one another. IBC up till about 2018 said, hey, you should look at UL 864, their design requirements, their design guide. It's a great way to model your stairwells. Well, after 2018, IBC said you shall comply with UL 864. So your equipment has to be listed to it, but it's not just your equipment, it's the programming and everything else that goes into it as well, the communication system. So when we look at UL 864, more specifically chapter 47, we can see a lot of different things that UL starts calling out. They call out for all kinds of different, for the communication, for the backups, for the wiring, for all kinds of different applications. And what it boils down to is basically everything inside this blue box is supposed to be listed to UL 864. Now, if you'll notice, the VFD is sitting outside that blue box. So it's just a motor controller. It does not have to be listed to UL 864. Now, what we've seen in the past is we've seen contractors and controllers take a system. They will say, hey, we'll take this VFD. We're going to add a couple of pressure sensors to it. We'll write a program for the VFD. The VFD will modulate up and down according to pressure. Well, what they've done is they've turned that VFD into a point logic controller. And so now that VFD, that program by UL and IBC needs to be listed to UL 864. So they need to call a listing agency out to have them come and test that system and certify that that works and works correctly. So what did we do? So we basically took our expertise from PID loop, from boilers, water heaters, all of our laundry room systems, and we basically created a dedicated system. We called it the Active Compensated Stairwell Pressurization System. I dare you to say that 10 times fast, so we call it the ACSP for short. But some of the nice features about the ACSP is that first and foremost is it can be paired with any fan out on the market. So as long as that fan is smoke rated, we can pair this control system with it and it works. The other nice feature is it's plug and play. So basically it consists of a point logic controller, 3 pressure transducers, a VFD, and a relief damper actuator if needed, if you've got a relief damper in there. The reason we want to use our actuator is proprietary to us, and it's a 2-second modulating actuator. So it's 2 seconds fully open to fully closed, can modulate, so we can react to changes in pressure very, very quickly with that system. When we take a look at how this system's kind of installed, it's very simple. Basically, we've got a VFD at the fan. We have pressure sensors high, medium, and low in the stairwell. And then we're going to have our 864 mounted somewhere near the FSCS, usually in the fireman's closet, somewhere where all the control systems are, so that the fireman can be able to see the system, be able to react to it, be able to, shut it off, change it, whatever needs to happen, however the firemen want to override it. The panel itself, it's got a 7-inch touchscreen. It's basically listed for and certified to UL 864. The entire system is. One of the nice features about this is it's got a dedicated I/O for the FSC panel, also for the fireman's pull. It also allows you to do your weekly or monthly testing without actually activating the entire system. So you can go into this panel, you can set it, run your test, feed that information to your BMS and have that logic and have those reports without having to activate the fire system, and call the fire department, things of that nature. Now, when we get that system works great for buildings up to about 12 stories. But when we get beyond 12 stories, what happens is our natural stack effect becomes greater than 0.3 inches between the top and bottom floor. So what we have to do is we have to introduce our L850 controllers with pressure transducers. And basically how that lines out is, if you'll remember, I said that we can do a injection point every 3 floors. Well, what we would do is we would have our L864 control the pressure inside the ductwork itself. And then at each of the injection points, we would have an 850 controller and an injection point damper. And that damper would open and close at that injection point based on pressure in that zone. So basically what you do is you zone off that stairwell. So now we can do, 20, 30, 40 floor, 50 floor buildings, zoning off that stairwell and basically keeping that system right where we need to be. Because another thing that we need to keep in mind is fire creates its own pressure. So whatever floor the fire is on, we're going to see a pressure increase of anywhere between 40 and 50%. So with zoning that off in these larger buildings, we prevent short cycling. We can also basically keep the pressure on that floor better than trying to pressurize that entire stairwell. When we're talking about elevator hoistways, basically the same kind of situation. So the only thing that we need to keep in mind with elevators is elevators have a little tighter pressure window. So they don't want to go above about a 0.25 inches on the elevator shafts. If you do, you're going to start to see door failures in that case. So how to specify? Well, basically we created here at RM Manifold, we created a stack calculator. We've got a team of engineers that do calculations. And basically this calculator we can send out, you can kind of plug in your basic building criteria, set temperatures, size of the building, number of floors, floor height, and it will kind of spit out a solution for you, kind of saying, hey, this is where you're at, this is what you need to be aware of. When it comes to specifying, again, our engineers can help you with all the fan scheduling and notes, but basically we go in the fan schedule under the notes. Basically choose your fan, like I said, you name the brand, and then we would be in the notes as the control system that goes along with those fans. We also provide full wiring diagrams with our systems. So you'll have a full wiring diagrams. You'll see we'll spell out everything that needs to be spelled out so that there's very little questions. We also do written specifications. So we can help with all full written specifications. And with that, that's what I've got.
All right, thank you, Scott. Lots of great information there. If you do have any projects forthcoming, please reach out to your long sales engineer to assist with any of that. One thing I would like to know, if you're not aware already, that DFD did change or updated their building codes. So all projects submitted January 1st, 2026 must comply with the 2025 DFD codes. That being said, the hoistway pressurization is still referenced in the DBC 403.6. It may be possible to eliminate with full fire protection engineering rational analysis. However, in the context of the LF system pressurization controls, this system is more applicable with DFD's kind of my way or the highway approach. So it's going to be replaced by engineering. So if you have any questions on that, please reach out to your long sales engineer as well. And then join us here next week. We're going to have Bill Rohn and Swig on to discuss some energy recovery ventilation. Thank you guys. Thank you, Scott, for your time. And I hope everyone has a great day.
You as well. Thank you.
Thanks.